formula. These are all the formula listed out for the indefinite integral over here.
It's 5 p.m.
Okay, so we can integrate any kind of algebraic term or algebraic function, okay, as long as it is corresponding, all right, to the form listed over here. For example, like this one, okay, 6x, okay, 6x to the power of 1, all right, 6x to the power of 1 over there. Okay, we can integrate it by using this formula. Which formula? Okay, formula number 3. Okay, formula number 3. Because 6x to the power of 1 resembles the formula which is ax to the power of n. This is the one. Okay, so a over n plus 1 times x to the power of n plus 1 plus c. So what am I going to do to integrate it? Like above here, okay, 6x to the power of 1 dx is equal to 6 over 1 plus 1 times x to the power of 1 plus 1 over here. Just follow the formula, but make sure you identify the form of the algebraic term and algebraic expression to be integrated correctly. Because if you use wrong formula, and then it will become wrong answer for integration. That's it. Okay, so now what are we going to do? Okay, we are going to solve our problem. Okay, we are going to solve our problem regarding integration over here. Okay, we are going to solve our problems, some of the problems over here. Okay. Okay, I will be opening one or two questions. Okay. This is the first question. Okay. This is the first question over here. Okay. Which is read like this. Okay, given that dx dx 7x is equal to gx, so find the integration or the integral of gx or dx like that. Okay, so over here, sorry, this is from the previous class here. Okay, I think I need to reduce the brightness a little bit. Yeah, this is a question. Okay, so given that d delta x, sorry, not delta, d dx 7x is equal to gx, so find the integral of the gx dx over here. So logically, for an integration, okay, integration is the reverse of differentiation. Okay, this is differentiation. Okay, differentiation is the reverse of the integration. Differentiation is the reverse of the integration. Okay, meaning when I have a function, say that function y over there, function y, I differentiate it, and then I got a. I got A, for example. Okay, just for a kind of what do we call that, analogy. So if I integrate A back with respect to X, and then I'm gonna get Y back plus C, like that. Okay, this is for the indefinite integral. I don't have the upper part and the lower part over there. So when I don't have the upper part and lower part over there, so um I need to plus C at the end of the question, at the end of the answer, like this. So the question asked now, given that dx 7x is equal to gx, find the integral of gx dx, like that. Okay, integral of the gx with respect to dx, it is 7x plus c. Okay, 7x plus c. Okay, that is how to solve this question. All right. Okay, so now we are going to move to the next question. Okay, it is given that integral of 4 bracket 8 minus x squared dx is equal to p bracket 8 minus x close the bracket q plus c, where p, q, and c are constant. Okay, given that the integral of this phrase is equal to p bracket 8 minus x close the bracket to the power of q plus c, where p, q, and c are constants. Okay, find the value of p and of q over here. All right, so first of all, okay, we refer back to our mind map over here. Or how, or the method of integration over there. All right, bracket ax plus b close the bracket n plus 1 to the power of n plus 1 over a bracket n plus 1 plus c. So return back to our question over here. So we are going to have, okay, our integration there. 4 bracket 8 minus x squared dx is equal to, okay, like 4 can be brought outside. The 4 can be brought outside. Okay, the 4 can be brought outside. All right, so over here, okay, we can see that leaving only 8 minus x to the power of 2 dx over there. So, like just now, okay, like just now, Okay, ax plus b to the power of n dx. Okay, we will apply this formula. Okay, we'll find out which one is the a, which one is the b, and which one is the n. Okay, so a is the coefficient of x. A is -1, b is 8, and n is equal to 2. So 4, put it outside there. So to integrate 8 minus x inside the bracket raised to the power of 2 dx. Okay, so ax plus b in bracket raised to the power of n plus 1 over a in bracket n plus 1 plus c. Okay, I'll mark this one by using the color over here. Okay, so now, okay, what are we going to do? Take 8 minus x to the power of 2 plus 1 over a is -1. Okay, similar to the formula over here, in bracket n plus 1, which is 2 plus 1 over there. Okay, making it equal to okay, make it equal here to 4. Okay, 8 minus x to the power of 2 plus 1 is 3 over -1 times 2 plus 1 is 3. Okay, like this. Okay, 4 bracket 8 minus x to the power of 3 over -3. -1 times 3 is -3. It will become okay 4 times 8 minus x raised up to the power of 3 or expanded to the power of 3 over -3. It will become 4 over -3. Four over -3, 8 minus x to the power of 3. Okay. So over here, okay, what will happen over there? Um, we are going to have our value of p. Okay. -4 over 3 will become the value of p. Okay. Sorry, this is an indefinite integral. So I forgot to say plus c. And this is the q. Okay, this is the q. Q is 3. -4 over 3 bracket 8 minus x close the bracket to the power of 3 plus c. So P is equal to negative 4 over 3 and Q is equal to 3. That is the one. Okay, that is how to deal with such questions like that. Okay. All right, now, if you observe over here, this is just one example of the questions. Okay, we have lots more of questions over here. All right, I'll open the next question. Okay, this is the next question. Okay, I'll cut it out. Okay, like what I said before, let us refer back to our notes over here, our mind map. Integration is also used to find the equation of the curve on the basis of the gradient function of a curve. Okay, to find the equation of the curve on the basis of the gradient function of a curve over here. All right, so what are we going to do? Okay, in order to find the equation of the curve, we need to integrate back the gradient function of the curve over there. All right, so going here, it is given that the gradient function of a curve is dy dx equals to hx minus 6, where h is a constant. Okay, look carefully, So if the curve has a turning point 3.1, if the curve has a turning point of 3.1, find the value of h and the equation of the curve. Okay, so now at the turning point of the curve, there's one principle that we need to bear in our mind while answering this question. Okay, at the turning point of the curve, at the turning point of a curve, the dy dx, or the gradient of the curve, will always become or will always be equal to 0. Okay, will always be equal to 0. All right. So over here, meaning since the turning point is 3, 1, the coordinate of the turning point is 3, 1. So at the point 3, 1, at the point 3, 1, so dy dx is equal to 0. So what is the gradient function, or what is the dy dx? Okay, what is the gradient function, or what is the dy dx? Okay, so the gradient function, okay, the gradient function or the dy dx will be equal to hx minus 6. So when dy dx is equal to 0, it means that hx minus 6 is equal to 0. Okay. And when is the hx minus 6 is equal to 0? At the point 3, 1 over there. Okay, at the point 3, 1 over there. Okay. So here, okay, if you observe, we are going to place 3 into the place of x in the function of hx over there. Okay. So it has now become 3h minus 6, which is equal to 0. 3h minus 6 is equal minus 6 is equal to 0. So 3h is equal to 0 plus 6 is 6. So h is equal to 6 divided by 3. H is equal to 2. So we have answered question A. H is equal to 2. Okay, this is question A. Okay, over here, now we have known that H is equal to 2. Okay, let us try to find the equation of the curve over there. Okay, this is equation B. Sorry, question B. Equation of the curve. Okay, for question B, we have known that the gradient function is equal to dy dx is equal to 2x minus 6. Dy dx is equal to 2x minus 6. Okay, so integrate it with respect to dx. 2x minus 6 with respect to dx. So it will become x, sorry, this is 2x plus 1, yeah? Okay, how to integrate it? Okay, 2x to the power of 1 plus 1 over 1 plus 1 minus 6. 6 has nothing or no x with it. Okay, so this means that the 6 is multiplied by 1. This means that the 6 is multiplied by 1. Okay, so x is equal to 0. 1 is equal to x to the power of 0 over there. Okay, so substitute the substitute the 1 with x equals to 0. Okay, 0 plus 1, okay, over 0 plus 1 over there. Okay, and then do not forget, because this is an indefinite integral, please plus c. Okay, please plus c. Okay, so it will become 2x squared over 2 minus 6x to the power of 1 over 1 plus c. Okay. So these two up and down can be cut out. It will become x squared minus 6x plus c. Can we find the value of c? That is a question. Yes, of course. We can find the value of c over here. How? Okay, we can find the value of c over there. All right. Okay. By having or using the point 3, 1 over there. Substitute the 3 into the place of x there. So 3x squared minus 6x plus c is equal to 1. All right. 3 squared is 9 minus 6 times 3 is 18. Okay, plus c is equal to 1. 9 minus 18 is negative 9 plus c is equal to 1. So c is equal to 1 plus 9. C is equal to 10. All right. Okay, over there, it will become, so for the full equation is x squared. It will become x squared minus 6x plus 10. That is y is equal to x squared minus 6x plus 10. Okay. I'll number back the number of steps over here. Okay, this is step 1. Okay. Step 2. All right. Step 1, step 2, step 3, step 3, 4, and step 5. Okay, that is the one. All right. That's how we use the concept of integration in order to solve the problem regarding regarding the equation, the actual equation or the original equation of the curve. Okay. All right. So this is the next question. Now we are dealing with the definite integral. So how about definite integral? Let us check out the red colored portion of this mind map. Okay, for the definite integral, you are going to have the upper quantity or upper number and the lower quantity over there. All right. So when you integrate an algebraic term or an algebraic expression fx, okay, with the b as the upper number and a as the lower number, so you need to integrate them. Okay, integrate it and then put b as the upper limit and a as the lower limit and then minus them together. So let us look at here. Sorry, not this question. I mean this one. Okay. Right now, yeah. For this part, given that integral 5 above and 1 below mx dx is equal to 9, okay, find the value of integral 1 above and 5 below mx dx. The value. All right. So this is A. Okay, this is A. If the integral of mx dx with the upper quantity is 5 and lower quantity is 1 is equal to 9. So if we make the upper and the bottom quantities inverted like this, 1 above 5 below mx dx, so it is going to be negative 9. That's it. All right. And then for B, okay, for B, the value of k if integrate 5 above 1 below kx minus mx dx is equal to 20. Clearer. Okay, this is step 1. Step 2, separating the terms, each term, okay, separately in the algebraic expression. Step 3, 4, 5, 6, 7, 8. So k is equal to 64 over 24, like that. Or simply saying 8 over 3. Okay, without further ado, for the remaining 21 minutes, let us go towards the SPM formatted questions regarding the topic of integration. Okay, this is the one. Okay, this is a question. Where is it? Okay, this is the one, the question. Diagram 1 shows the curve y is equal to fx, okay, intersects with uh, the x-axis at P and Q. Okay, diagram 1 shows the curve y is equal to fx, intersects the x-axis at P and Q. Okay, when we say the function or the curve y is equal to fx, intersects the x-axis at points P and Q, it means that when y is equal to 0, the x must be equal to P or the x must be equal to Q. That's it. X intercepts are the values where x intercepts are the values where what do we call that? All the part over there, x intercept are the values where the y is equal to 0. Okay, so now given that the area of the shaded region above is 12 units, find the value of integral 4 fx dx. Above is q and the bottom one is p over there. Okay, okay, that is we want a over here. Okay, the area of the shaded region is 12 units. Find the value of integral q p 4 fx dx over there. Okay, so now there is another principle that we need to understand. What is it? Integration is used to find the area under the curve. Okay, integration is used to find the area under the curve. So the area under the curve will only becomes positive when it is under the curve. The area is going to become positive only when it is under the curve. But like this, the area is above the curve. The shaded region is above the curve over there. So the area of the shaded region is 12 units. Okay, so over there, Q above and P below. Okay, Q above and P below. This is a function fx. Okay, dx. So usually when the area of the shaded region is above the curve, okay, it means that the value of 12 is negative. Okay, when the value of negative 12 when the value of 12 is negative, so now we are urged to find the value of the integral of 4 fx dx over there, when the above part is a q and the bottom part is p. Okay, so above part is q and the bottom part is p. Okay, q p 4 fx direct to dx. The 4 can be brought outside. The 4 can be brought outside. Above here is q, below there is p. Okay, fx dx. Okay, 4. Just now we have known the value is negative 12. So put it negative 12. 4 times negative 12 is negative 48. That is the value of the integral above q, below 4, 4 fx with direct to dx. All right. So now we are going to have another question, which is find the integral of above k, below 1, x plus 2 in the bracket direct to dx in terms of k. Okay, so what are we going to do over here? Okay, here we are going to integrate the x plus 2 first. This is x x, when it has no power, we assume that it is raised to the power of 1. 1, okay, x to the power of 1, n is regarded as 1 plus 1 over n plus 1 over there, plus 2, no unknown of x is regarded or is multiplied with 2. Okay, 2 times 1, okay, 2 times 1, okay, 1 is equal to x to the power of 0. Okay, x to the power of 0. 2x to the power of 0, 0 plus 1 over 0 plus 1 over there. So no need to add c, no need to add c, because this is a definite integral. This is a definite integral. Okay, so please be very, very extra careful over here in order to prevent any mistakes that will lead to mark loss. Okay, k above, 1 below. K above and 1 below. Okay, so x to the power of 2 over 1 plus 1 is 2 plus 2 x to the power of 0 plus 1, x to the power of 1 over 1. X squared over 2 plus 2x above k below 1. Okay, x squared over 2 plus 2x above k below 1. So now substitute k into the place of x minus the same equation, substitute 1 into the place of x. All right, over here. Okay, place it into the put it into the place of x over there. K squared over 2. Okay, plus 2 times k. Okay, minus 1 squared over 2 plus 2 times 1. Okay, k squared over 2 plus 2k. Okay, k squared over 2, okay, plus 2k. All right. And then, okay, it will be minus 1 over 2 plus 2. Okay, k squared over 2 plus 2k minus, okay, 1 over 2 plus 2, you make it in the form of a fraction which denominator is 2. So it will become 1 plus 2 plus 4 over 2. 2 is regarded as 4 over 2. Okay, k squared over 2 plus 2k minus 1 plus 4 is 5. 5 over 2. That is the one. That is a final answer over there. Okay. I will relist the step one by one. First one is this step. Second one is this step. Third one is substituting steps. And the fourth one is this step. Okay. Okay, now this is question number 11. Okay, question number 11 over here. All right. As for the question number 11 over there, given that integral p above and 2 below fx dx is equal to 6. Okay, so I'll cut down first the picture. Okay, I'll snap the picture first. Okay, given that integral integral fx dx above p below 2 is equal to 6, and integral fx plus 2 dx above p below 2 is equal to 10. Find the value of p. Okay. P fx dx 6 f integral of fx plus 2 dx p above and 2 below is equal to 10. Find the value of p. Okay, find the value of p. All right, so over here, we need to, we have another 5 minutes more before the end of the lecture. So I need to solve this quickly. All right, so integral above p below 2 fx, spread it directly, plus 2, okay, above p below 2, 2 dx is equal to 10. Integral fx dx above p below 2 is equal to 6. 6 integral 2 above p below 2 dx is equal to 10. Okay, integral above p below 2 dx is equal to 10 minus 6, which is 4. So we integrate first. This will become 2x. 2x above p below 2 is equal to 4. Okay. Put put p or substitute p into the place of x. 2p minus 2 times 2 is 4. Okay, 4 2p minus 4 is equal to 4. Okay. 4 plus 4 is 8. 2p is equal to 8. P is equal to 8 divided by 2. Okay. That is the one. Okay, for last one over there, uh, within these 2 minutes, what am I going to tell you? Okay, the curve if xy is equal to 4. Sorry, the curve is xy is equal to 4. So xy is equal to 4. When it cuts the, yeah, the area is cutting at the y-axis, so we need to convert it into x. It will become 4 over y. Yeah, it will become 4 over y. All right. So above here is 3, below there is 1. So you want to calculate the value, the generated volume. The value is over here. So we need to follow this formula directly. We need to follow this formula directly. So integration 3, 1. Okay. Pi outside there. X squared is 4 over y squared, and then dy. Okay. All right. Over there, so it will become 16 over y squared. Okay, integration